Hello, we are here for one more lesson of this SprutCAM training course. The topic for today will be the lathe machining. So this is a new chapter, new type of milling toolpaths, new type of machine. Lathe machining is used for turning workpieces, usually metal, but for sure we can have other materials. And the best definition I can say it is we obtain, I would say, it is the general idea, revolution shapes in this type of machine. We will use this part that we have now in our drawing area. It's a pawn, a chess pawn. I think it will simulate most of the things we want to see in this video. So first thing to create toolpaths in terms of lathe or turning, it is to choose a proper machine. As you know, and as we've seen, there are machines defined with certain characteristics. So either can be a milling machine, turning, only a turning machine, or lathe, turning and milling. So it depends on the schematics and on the behavior of the machines, on the kinematics of the machine. So we have a lot of different parameters to set so that the machine is properly defined in terms of the movements, and that those movements, when the toolpaths are post-processed, respect the kinematics of the equipment. So we will jump that part of the machining configuration, and we will see today the different types of toolpaths we can obtain with the turning or lathe operations. So when we choose this type of machine and we go to a new operation, we have a new group called lathe, and we have a lot of different types of toolpaths. And we have, I would say for the majority of them, this OD and this ID. So OD outer diameter, ID inner diameter, okay? All the rest of the concepts, for example, the workpiece, it remains the same. So we have a workpiece to start the machining, which will be updated according to the different toolpaths we are going to create. So let us see a couple of examples. Lathe facing, simply, I will say run and see the result. I will not be worried about the parameters now. So facing, it simply will do like this, and I will update. As you can see, I'll turn now the workpiece off so that my workpiece is updated. So it will simply clean this face in this part. So we can, for example, simulate this. Okay, simple toolpath. A new one called roughing, and roughing will do something like this. It will approximate the shape by levels. So if we go here, we'll speed up this a little more, and it will work like this. Okay. Then we have also we have a roughing program, inner and outer. Then we have a finishing that will follow the shape. So simply run. As you can see, it depends on the shape, and it depends on also on the shape of the tool, because even that we have this shape here, the tool that we've chosen cannot come into this area and take this material, because probably it will make a collision. So, and here the same. So either we should have another type of tool, or it happens like the thing you are seeing now. So another one, it is so finishing. Now the grooving will work around this area here, and a little less visible around here. It will take a part of the material in this area. So now we should create a finishing toolpath to make a proper roughness on this part of, of this shape. Let's try to simulate. Okay, now I will pass only this one so that you can see the type of behavior. Oh, too fast. I'm not sure if it is. No, not doing anything already. Okay. Then we have also, besides the grooving, we could do a face grooving, which in this part I don't have, but basically it's a grooving on the face. Instead of coming to the perpendicular direction, it will go into the parallel direction. We have a threading, a hole, and a part off. The part off I can show you here. So the part off, it is an operation that basically will split the part from the workpiece. Okay. Let us try to show the part off. Okay, simply separate the part, and that's it. I will open a new geometry, which I don't know, I think it's okay, I think it's this one. I will open this one, and I have a couple of toolpaths which I will delete because I don't want them. Before I show you the two other toolpaths, just showing this kind of possibility. This part not visible, but I will show you on the other one. So I can create also a threading, outer diameter or inner diameter, doing a threading, and simply go and do something like this. This shape is not the proper shape to make a threading, but I can show you. We take this out. Okay, it was on the other side. You can see that I have multiple passes with a proper tool to create this threading, supposedly in all the shape, but as you understand, it will be, or it should be, on a flat surface. Anyway, the example, I think it is clear. We can try to simulate it a little slower. Okay, and it will work like this. Multiple passes to open the thread. You see that behind it will make problems, but the idea which I would like to show you is this area where it's trying to open in several passes a thread. Okay, it's not the proper example, but I want that you can see the movement of this thread. Finally, we have also another type of toolpath, which is the lathe hole machining. In this geometry, we have a hole, so we can and we should create a center. If we open, we can give some parameters as in all the others toolpaths. Anyway, I can choose a center, which can be this one. Okay, just close and do the run. and it should be calculated, as you can see, and we will simulate the movement. Okay, that's it. As you can see, for sure we could do this in more than one pass, but the concept, it is this one, a tool which can through the Z-axis to make the hole. And these are the different turning toolpaths we can have in turning operations. So we'll have more videos about the turning operations, and we'll see some of the most important parameters in these next upcoming videos. This set of toolpaths, I think, give you another baggage of operations which you can use to create your parts if they are revolution parts. Any question or any help that you may need about these concepts we've talked about in this video, you can reach us through the usual contacts. So let us know any questions or any comments that you may want to send us for analysis or for help.